Motors used in electric vehicles. In this video, I am going to discuss about brushed DC motor and different types of the electric motors used in electric vehicles. What is brushed DC motor? Brushed DC motors are one of the simplest types of DC motor. It uses brushes to deliver current to the motor windings through mechanical commutation. The number of coils wound around the motor and the density of the coils determine the properties of the motor. The armature or rotor is an electromagnet. The field magnet is a permanent magnet. This motor does not require any controller to operate or vary the speed. And the construction of the DC motor is it typically consists of a pair of permanent magnets named as stator and a motor coil named as rotor connected to a commutator. In this motor, armature winding is on rotor and permanent magnet are always on the stator. So coming to the working principle of the DC motor, when power supplies the motor through battery or any DC source, electricity flows from source to the armature through brushes, which generally locates on opposite side of the motor shaft. Brushes are very important part of this motor. These brushes transfer electric current to the armature through physical contact with the commutator. As soon as the armature coil gets energy or power, it begins to behave like a magnet. And at this point, its pole starts repelling the poles of the permanent magnet, which makes up the stator. As the poles repel, the motor shaft where the armature coil attached begins to rotate with a speed and torque. The speed and torque depends on the strength of the magnetic field around the armature. Generally, the strength of the magnetic field is a function of the voltage applied at the brushes and the strength of the permanent magnet used for the stator. And coming to the advantages of brushed DC motor, low overall construction cost, can often be rebuilt to extend life, simple and inexpensive control not needed for fixed speed, ideal for extreme operating environments. Coming to the limitations of brushed DC motor, less efficient, electrically noisy, and lifespan, as they are in the preferable physical contact with the shaft, brushes, and commutator wear out. So, coming to the applications of the brushed DC motor, through these motors mainly used in household appliances and in automobiles, these motors still used for industrial purposes for both low and high power, fixed and variable speed electric drives. They still use for paper machines, cranes, electrical propulsion, sewing machines, power tools, and steel rolling mills. Different types of electrical motors used in electrical vehicles. Brushless DC motor BLDCM, permanent magnet synchronous motor PMSM, AC induction motor ACIM, interior permanent magnet motor IPMM, permanent magnet switched reluctance motor PMSRM. Now coming to what is brushless DC motor. Brushless DC motors, also known as electronically commutated motors, Primary efficiency of this is most important feature of BLDC motors because the motor is the sole bearer of the magnets and it does not require any power. That is, no connections, no commutator, and no brushes. In place of these, the motor employs control circuit to detect where the rotor is at certain times. BLDC motors employ, along with the controllers, rotary encoders or Hall sensors. What is the construction of the brushless DC motor? In this motor, the permanent magnet attached to the rotor, the current carrying conductors or armature windings are located on the stator. They use electrical commutation to convert electrical energy into mechanical energy. The main design difference between the brushed and brushless motors is replacement of mechanical commutator with an electric switch circuit. A BLDC motor is a type of synchronous motor in the sense that the magnetic field generated by the stator and the rotor revolve at the same frequency. Brushless motor does not have any current carrying commutators. The field inside the brushless motor is switched through an amplifier which is triggered by the commutating device like a optical encoder. The working principle of the coming to the working principle of the brushless DC motor. The brushless DC motor works on the principle similar to that of a brushed DC motor. The Lorentz force law, which states that whenever a current carrying conductor placed in a magnetic field, it experiences a force. As a consequence of reaction force, the magnet will experience an equal and opposite force. In the BLDC motor, the current carrying conductor is stationary and the permanent magnet is moving. When the stator coils gets a supply from the source, it becomes electromagnet and starts producing the uniform field in the air gap. Through the source of the supply is DC, switching magnet makes the generator an AC voltage waveform with a trapezoidal shape. Due to the force of interaction between the electromagnet stator and permanent magnet rotor, the rotor continues to rotate. With the switching of windings as high and low signals, corresponding winding energized as north pole and south poles. The permanent magnet rotor with north and south poles align with stator poles, which causes the motor to rotate. And coming to the advantages of brushless DC motor, less overall maintenance due to absence of brushes, reduced size with far superior thermal characteristics, higher speed range and lower electric noise generation. It has no mechanical commutator and associated problems, high efficiency and high output power to size rotor due to the use of permanent magnet rotor. High speed of operation even in loaded and unloaded conditions due to the absence of brushes that limits the speed. Smaller motor geometry and lighter in weight than both brushed DC motor and induction AC motors. Long life as no inspection and maintenance is required for commutator system. Higher dynamic response due to low inertia and carrying windings in the stator. Less electromagnetic interference. Low noise due to the absence of the brushes. Now, limitations of brushless DC motor. These motors are costly. Electronic controller requires to control this motor is expensive. Requires complex drive circuitry. Need of additional sensors. What are the applications of brushless DC motors? Brushless DC motors used for a wide variety of applications required such as varying loads, constant loads, and positioning applications in the fields of industrial control, automotive, aviation, automation systems, healthcare equipments, etc. And another one, computer hard drives and DVD or CD players, electric vehicles, hybrid vehicles, and electric bikes, industrial robots, CNC machine tools, and simple belt driven systems, washing machines, compressors and dryers, fans, pumps, and blowers.